The integral from e to the negative 3 to even e to the negative 2 of 1 over x log x dx is equal to one of these values. Right. So my first thought here is we might not be able to find directly an antiderivative of this super easily, but maybe there's a substitution we can make that turns this integral into something a little bit more reasonable, something where we can easily make a substitution. And I'm seeing now the I want to make a substitution so that we can find an antiderivative easily. And I'm pretty sure the appropriate substitution is just going to be for log x, because we have a 1 over x in this expression, and that's the derivative of log x. Okay, so I get log of 2 over 3, which is one of the answers given. Couple things trip me up a little bit, and if I wanted to be super careful, I would go back and really think about this. But of course, on an exam like this, maybe you don't want to spend that much time. So I was kind of just more or less blindly going through the substitution technique. Like I said, I made the substitution that u is equal to log x, so du is 1 over x dx. As long as x is positive, there's nothing tricky about this. That's fine. First thing is we change the limits of integration. When x is e to the negative 3, the log of that is negative 3, so u is negative 3, similar for the upper bound, negative 2. Then when we integrate, we have to remember that when we're integrating over a negative domain, the proper antiderivative is the logarithm of the absolute value of u. I mean, I guess, yeah, alarm bells should have gone off if you just used the logarithm of u and then tried to substitute negative values. Yeah, and so just using that directly as the antiderivative, logarithm of absolute value of u, substituting the values, this is what I get, log of 2 over 3. And I suppose that also makes sense, right? Because, I mean, log of 2 over 3 is between 0 and 1. So the log of 2 over 3 is negative. And if you look at this integral, we're going to be integrating over an interval where this is negative. And so you expect the integral to also be negative. Yep, nice little problem. Not much more to say about this one. Thanks for watching.